Welcome to a new video. Today we are going to build a data science project. I will add the link of the dataset to the description. We will do data analysis, feature engineering and machine learning in this video. Let's directly start. We have a lot to do. Here is the dataset. I put it in here and you can download it from the description. We are going to start by importing the libraries. Import pandas. We are going to import NumPy. We are going to import Seaborn. And we are going to import matplotlib at the first stage. At the machine learning part, we are going to do the other imports. Let's use read CSV, pd, read CSV, Europe, motorbikes.csv. Here it is. So you're probably going to see it from the title. Our dataset is about motorcycles. Let's see the first 5 entries here. We have columns like price, mileage, power, make, model, date, field, year, offer type, version, and a link of it. Great, let's get general information about the columns and the data. We are going to use df.info for that. Here it is. So with .info we can see information like how much memory it uses, how many data types in each type we have, and more. Let's use df.shape for seeing the row and column count. As we can see, we have around 35,000 rows and 10 columns. Let's get the summary statistics for the numeric columns. Like we have 3, we have 1 float and 2 integers in here. We are going to get the summary statistics for them. We are going to use df.describe method for that. And here it is. So for example, this means that we are going to take this number and this is going to be multiplied by 10 power of 4. And this is that number's full version. Like we can change this scientific notation with one line of code here. We can say that pandas set option display that float format, and we will say to floating, and we will say that format here. And now we are going to see that our numbers are going to be changed and they are going to be in the float format with 2 floating. Here it is. Also you can see that the thing we got here, the count of the price is 34,917 as we calculated. You can use this line for changing the scientific numbers to the floats we know. Great, let's talk about this numeric summary. We have 3 columns that are numeric and the average power is 206. Great, so we can move on. Let's check for missing values. We will say data frame is null and we will use .sum here. We have 6,000 missing values in the power, 3,000 missing values in the field, 22,000 missing values in year, and 17,000 in the version. I'm not going to drop the missing values because we are going to lose some really important information with dropping them. We are just going to keep them as null. Like if you say drop NA, you are going to drop 22,000 rows maybe with 17,000 and you are going to lose 40,000 rows for nothing. Year and version isn't that important, I think. Okay, let's check for the duplicates. df duplicated, and we will use some method from here. And we can see that we have 5,800 duplicates. We can remove them. We are going to use drop duplicates method and we will say in place equals to true. So we are not going to assign it again. So we can check if it's worked like duplicated .sum, and this is going to show us 0 this time. Great. Okay, let's do a data visualization. Let's create the count plot of the field types. We will say SNS count plot and we will say X is going to be equal to the field and we will say data is going to be equal to the data frame. Let's set the X label as field type and Y label as count, and let's give it a title like count of motorbikes by field type, and let's set X text rotation 45 and use plt.show here. Here it is. Great, now we can see the fuel type distribution of the motorbikes. We can see that it's dominated by the one fuel type. Okay, let's group by gear and calculate the average power of the motorbikes. Let's say gear power and df group by gear. We will take the power mean. And let's get these values like gear power. Here it is. Great, we can see that in the motorbike power mean terms, semi-automatic is the leading one and the automatic is the less powered one. Okay, we can move on. So let's sort our data set by price in descending order. We will say df sort values. We are going to sort by price column and let's set the ascending as false. Here it is. So we can see that here are the prices we have in ascending order, and let's check our original data frame. It's randomly sorted. So what if we want to save this sorted version? It's simple as in place equals to true, and from now on our original data frame is going to be look like sorted like this. Great. So these are the outlier values and we normally shouldn't include them in any of our analysis or any of the modeling side. I'm just not going to remove the outliers because it's going to take a lot of time and video is going to be really long, but in the future projects I can do that if you want. You can tell me in the comments section. I'm just going to model like this. I don't think it's going to change a lot of things because some of the models are understanding the outliers and treating them, and maybe we don't need them in some of the models like we need it in some of the models. I can do that in the future projects, but just for keeping this video short, I'm not going to do that. But if you really want to create a great model and better analysis, you can just remove them. You can use intercoil range and you can use other outlier removing methods, and you can take this project a step further. Great, let's move on. Let's take the value counts of offer type. So we will say offer, also I'm just going to remove this intercoil range, offer counts, and we will say df offer type dot value counts, and let's get offer counts. Also I need parentheses here. Great. So most of the motorbikes are used as you can see, and we have some new in here. We have demonstration. Great. By the way, I don't really know about motorbikes, so I'm just going to get the first two entry of our data. It says used in here for the offer type, but maybe they can be classic and these prices can be true for some motorbikes, because I know that some classic cars gets this amount of values. So maybe it can be. Like collection items can get crazy monies. So this is a probability, I think. I'm not sure. As I said, I don't know anything about the motorbikes. I know some, but I don't know a lot. Great, let's get the value counts of make model. We will say make model counts. We will say df make model, and we will take the value counts like this and get the make model counts here. Great. Also, if you don't want to see this amount of list, like we have 2168 unique values in here, we can just say head and 5 for seeing the first 5 like this, and you can include them in your analysis. You don't need to put all of them actually. Great, now we can do some group bys. Let's group by fuel and calculate the average price for each fuel type. Let's say fuel average price, and we will say df group by fuel, and we will group by price mean, and let's say fuel average price here. Great. So let's also sort this. Sort values ascending false, and see the result here. Here it is. So the thing has the most price is LPG. I think that's because of the classic cars. I'm not sure. Great, let's group by year and calculate the median mileage for each year type. Let's say year median mileage, and we will say df group by year, and we will say mileage dot median. Year median mileage. Also, I made a typo there. Great. I think this is an accurate result because manual motorbikes used much. Great. Also, we can check quickly like what happens if we take the mean instead of median. You can see that here. Okay, let's group the data by offer type and calculate the maximum power for each offer type. For that, we are going to say offer maximum power df group by offer type, and we will say power, and we will use the maximum method here. Offer max power. Here it is. Also, we can sort this in descending order. Sort values, ascending, false. And it's going to be sorted right now. Great. Okay, let's group the data by make model and calculate the average price for each motorcycle model. We will say model average price df group by make model, and we will group by the price, and we will take the mean here like this and get the model average price here. We have 2000 here, so we can sort the values firstly in descending order and take only the 5 here like this, and you can see that we got the data we wanted. Okay, let's group the data by fuel and gear together and calculate the count of motorcycles for each combination. Let's say fuel gear counts df group by, we are going to give 2 columns to group by fuel and gear, and we will say that size, and we will use unstack here fuel value 0 and get this fuel gear counts. Here it is. I think it looks great. A lot of information in here, like we can see electric, gasoline and semi-automatic like this in here. We can see gasoline, automatic in here, combination of them. By the way, I'm trying to cover most of the methods, like we are grouping by 2 columns using unstack, we are grouping by single column, and we are doing other methods because I want this video to be informative and it's my goal in this video. Okay, let's do some more data visualizations. Let's take the average price by fuel type in a bar chart. So we are going to go step by step. Let's group by fuel and calculate the average price. We will say fuel average price. We will say df group by fuel, and we will say price mean. And let's see the result, and then we can move on to the bar chart. Great. Also, we can do sort values here for getting the better bar chart. We can say ascending, false like this for doing in the descending order. And now we are going to create our bar chart. I will say fuel average price dot plot kind bar, and let's set the color as sky blue because it's going to look better. Let's say X label fuel type, and let's say Y label average price, and let's give it a title like average price by fuel type, and let's set the X text as rotation 45 and use plt.show here. Here it is. So I just want to show that this looks like that right now, but if we go here and say in place equals true and recreate our bar chart, you're going to see it's going to be in the descending order to the right. Okay, let's do another visualization. Let's take the maximum power by offer type and we create a bar chart with that information. Let's go step by step again. Let's group by offer type and calculate the maximum power. So we will say offer max power and df group by offer type, and we will take the maximum powers like this, maximum, and let's see what we get from here. Offer max power, here it is. So let's again sort it, sort values, and we will say ascending false, and we will set in place as true like this. And let's get what we have in the offer max power. Here it is. So used has a higher number than the others, so it's just going to look like this graph. So I'm just going to take this for making it better looking, and we are just going to remove the used like this. Offer max power is going to be equal to the tail 4. It's going to take this 4 entries, and we are going to run this, and let's check offer max power. Here it is. Great. Now create a bar chart with this. Let's say offer max power dot plot. We will say kind bar, and we will set the color as light coral, and we will say plt x label offer type and plt y label maximum power plt title maximum power by offer type, and x text, let's set rotation 45 and plt.show. Here it is. It's looking great. I think it was a good idea that removing the first entry here, like we are just taking this 4, and it's looking better. Okay, now let's do a final visualization, like let's use pie chart since we didn't use it in this video, and then we can get to the feature engineering and modeling side. So I will say I think we can do the pie chart of field type distribution. We can just use like field distribution, and we will say df field. We will use value counts here, and you can see field distribution. It's looking like this. So let's just take this again and don't put this one here, don't put gasoline here. We can just say tail and 1 2 3 4 5 6, and we can set this to the field distribution, and it's going to be look better like this. And let's create the pie chart. We will say plt.pie field distribution. We are going to set the labels as field distribution dot index, and let's say auto pct. We will say 1.1 floating percentage. Then we will say start angle, and let's say 140 color, and we will say gold. Let's take light coral and light green like this. And I think I made a typo. Yeah, here it is. Great. So we will say plt.axis, let's say equal, and plt.title field type distribution. Also say doesn't gasoline included. Also we can just say not instead of doesn't, because it's going to look better. And let's use plt.show here. So I made a typo there. I can just change this to angle, and now it's going to be better. I think color, it didn't work. I'm surprised because it's colors, and now it's looking great. So we have a nice looking pie chart, and we can get to feature engineering. So let's just call our columns and select the ones that we will include in the modeling. So let's set y firstly. Y is going to be the price here. It's a shorting, I'm just going to put it in here and run that, and it's going to be in here. Great. And let's set the X here. Also, I'm not going to set it as series, so I will just do like this, and I'm going to show you the difference. It was a series before, and now it's going to be a data frame like this. Great. And let's set our X here, like we can take my wage, power. Let's not include the make model. Also, we can, I'm not sure, let's not include it. Take my wage and power. Let's put fuel, and I'm not sure about the year. Let's put offer type, and let's also put year here. And I think it's enough. Let's just check X, and I think we made good decisions here. So the next thing we need to do here is we need to do feature encoding, because these are categorical variables and we need to change them to numeric if you want to use them. Also, we have really big differences in like my wage, power, and these are going to be like 1, 2, 3, 0. So we need to do feature scaling also. Let's import preprocessing from sklearn, import preprocessing, and let's set label encoder. Let's use label encoder preprocessing dot label encoder, and then we are going to go column by column. So we will do the encoding for the data frame fill, and how we are going to do is we will do label encoder, we will use fit transform method, and we will use it on the data frame fill. And I'm just going to make a copy paste here, and I'm just going to change the column names. Like here, I'm going to do that for the offer type like this, and I'm going to do that for the year. So I'm just going to do this, and we are going to see the new version of the data frame. Like you can see that fill year offer type, and I'm just going to rerun the X and Y didn't affect, but X affected. And you are going to see that we have the numeric values here. So we can do that before the X and Y selection. It's the same thing. And since we have only numeric X values, we can move on. Now we are going to use train test split to split our data. After that, we are going to scale our data because we don't want data leakage. So the train test split is going to let us evaluate our models. Like we are going to have a test set and training set. We are going to train our models on the training set, and we are going to test the performance of the models on the testing set. If we don't do that, we can't compare the models, and we can't know that how our model is performing. So we need this. We are using this a lot when we are doing modeling. So let's just do that. We will import train test split from sklearn.model selection, import train test split. We are going to say xtrain, xtest, ytrain, and ytest. We use train test split here. We'll say x, y, test size 0.2. This means that 20% of the data we have is going to be in the testing set, and the 80% is going to be in the training set. So let's just run this, and we can just check like xtrain, xtest, etc. It has 23,000 rows, and this has 5,800 rows. And the next step is the scaling our data. We will import sklearn preprocessing. We'll import standard scaler here, and we are going to do standard scaling, which we can also refer as standardization. We are going to initialize the standard scaler like this. Then I'm only going to scale the X values. Scaled xtrain is going to be equal to the scalar fit transform xtrain, and scaled xtest is going to be equal to the scalar fit transform xtest. Like this. Great. Now I'm going to define a function for evaluating our models, like it's going to give mean absolute error and root mean squared error when we call it, so we are not going to call these metrics every time. So I'm going to import from a scalar matrix, I will import mean absolute error and mean squared error, and we are going to define as model results, and we will give predictions to our model. We don't need to give y true values because we are going to give it right now. I will say print mean absolute error on model is, I'm going to use that format with this string. I will use mean absolute error, y test, and predictions. The predictions are the ones we will pass in our function, and also print root mean squared error on model is, we'll use that format again, we'll use numpy square root mean squared error y test, and we'll give predictions. This is our function. Great. Also just take this to here. I missed something, that we created this function but we are not going to have any NA values in the modeling side. So I'm just going to do a quick thing here. I'm just going to say, before any transforming and setting options, I'm just going to say df is going to be equal to the PD with CSV, and let's use like our CSV file here. I'm just going to take its name from here, copy, and we will say, and we have the brand new data frame here, like here it is. Let's just check it, and it's not label encoded, anything, etc. And after setting x and y, we are going to say x drop NA and use in place equals to true, and we are going to do the same for the y. We will say y drop NA, and we are going to set in place as true in here too. So we have x and y with non-NA values. So if we have NA values in the modeling side, it's going to raise an error and we are not going to train any models. So I just dropped that. I'm sorry for the confusion. You can drop it at the start of the selection of the x and y after selecting, because with that NA values you can train any models. Now we can start to the modeling. Let's start with linear regression. We will say from sklearn, also I'm going to use lowercase letters, from sklearn.linear model import linear regression, and we will say linear regression is going to be equal to linear regression. We're going to initialize this. And for the other models, I'm going to do hyperparameter tuning, but we don't have any parameters in linear regression. Actually, we have, but we don't have. So we will just say linear regression.fit, and we're going to fit this in our training data, and y train here, and let's fit linear regression like this. Then we will say predictions linear regression.predict scaled x test here, and we got our predictions in here like this. And let's say model results and predictions linear regression, and we can see our mean absolute error and root mean squared error like this. Okay, let's train a support vector machines model, but this time we are going to do hyperparameter tuning with grid search. Let's say from sklearn.supportVectorMachines import support vector regressor, and from model selection import grid search cross-validation, and we are going to initialize this like SVR model, and it's going to be equal to the SVR support vector regressor. I need equal sign in here. Great. And we are going to define a dictionary for our parameters. We will say C, and we will create a list like 0.001, 0.01, 0.1, and let's say 0.5. Also, we are going to give kernel, and there's going to be 3 options like linear, RBF, and poly. And we can say for other parameters, I think it's enough, but I'm just going to define more for showing you. I'm going to say gamma, and we can say scale and auto in here, and also we can set degree, and we can say 2, 3, 4 and 5. So this is going to be the final ones that I'm going to define. You can do a lot more, like you can add after this 0.5, and you can add before this 0.01, and also for the others. So what we have here is we have C, kernel, gamma and degree as our parameters. I think I didn't make a mistake on the writing side. I need this in here. Also this is, oh, I'm just checking it, and I think we are good to go here now. Okay, so after defining our parameters with SVR, I'm just going to check it quickly again. This, we have list. Okay, great. So the next thing I'm going to do is I'm going to create this like grid SVR, and I'm going to use grid search cross validation. Then I will say SVR model and parameters grid SVR. So now we are going to fit this into our data. We will say grid SVR dot fit scaled x train. By the way, this fitting operation is the model train part, and we will train our model like this. This is going to take a little bit time, and after the fitting operation I'm going to be in here. Okay, I'm back. It is trained like in 2 minutes and 4 seconds. So the next step what we are going to do is, also we can remove this warning, but it's not important for now, I guess. And what we can do now is we can print the best parameters, like we are going to use best parameters for model is, and we will say format grid svr dot best parameters, and let's see the best parameters selected. We have 0.5 for C, 2 for degree, scale for gamma, and linear for kernel. And the next thing we are going to do is we are going to make predictions with this model, and then we are going to evaluate its performance on the testing set. So we will say predictions grid svr, and grid svr dot predict scaled x test, and let's call our function predictions grid svr. Model results is the name of the function. Here it is. So here we got the results from our model. Let's train one last model for this video and end this video, because it's going to be too long and we can train other models on the other projects. Let's train a random forest model for the ending of this video, and we can train other models like decision tree and XGBoost in the other projects. So we will say from sklearn.ensemble import random forest regressor here, and we are going to initialize it like RFR model random forest regressor. Also I made the same mistake, I need a Q sign in here. Then I will say parameters grid RFR, this time random forest. We will set parameters like we have bootstrap. We are going to set true for this. I can explain this in another video on a random forest specific tutorial. I'm planning that. Max depth, we can say 5, 10 and 15 here, and maximum features we can say auto and this, and at the number of estimators time we can say number of estimators, we can say 3, 4, 5, 6, 7. We can say a lot more, but I just want it to train fast, and I will say grid RFR, and we are going to say grid search cross validation RFR model and param grid RFR. Then we are going to fit this like grid RFR.fit. We are going to fit this using our training data. I will say scaled x train. Also I made a typo there, x train and y train like this. and I'm going to be back when it's trained. Oh, it trained fast. So the next thing I'm going to do is, let's take the best parameters. Let's say print best parameters for model is, and we will use that format grid rfr.past parameters, and we are going to see bootstrap true. That was the only option. 15 for the max step, this for the maximum feature, logarithmic 2, and the 4 for the number of estimators. Great. By the way, I'm calling this as this because I don't remember that it was logistic or logarithmic. I'm just going to quickly check it and tell it to you. Okay, I remember it correctly. It's the logarithm base 2 of the whole number of maximum features, and we can just say logarithm 2 for that. And now the next step, we are going to make predictions using the scaled X test. Let's say predictions grid random forest, and we will use grid random forest predict scaled X test. And let's get the model results for the random forest model. We will say predictions grid RFR, and we can see that we got higher numbers than the support vector regressor. I think it's the end of this video. I can do like decision tree regressor too, but it's already longer than 1 hour, so let's just finish this project in here. So we made a lot. We made exploratory data analysis, we made some data visualizations, group bys, sorting operations, multiple group bys, then we did feature scaling, and then we did modeling. In the video we used linear regression, support vector regressor, and random forest regressor. And I think that was a great project, and I hope you enjoyed it. I have a project of data science projects, and I have more than 10 projects on that playlist. You can visit that playlist for seeing more projects about data science, and I'm creating content about data science and programming. You can subscribe to my channel for more videos like this. Have a great day.